Today, we're cracking open something you probably use every single day, something that honestly probably feels like a bit of annoying magic. You absolutely know the drill, right? You type in your username and password, hit enter, and then bam. The website abruptly stops you in your tracks, demanding a 6-digit code from that Authenticator app on your phone. So you scramble, you open the app, frantically type in the numbers before that little pie chart timer runs out and turns angry red, and boom, you're finally in. But have you ever stopped to wonder what is actually happening behind the screen during those intense few seconds? Okay, let's dive right into this, because to figure it out, we have to start with a massive paradox. How does your Authenticator app generate the exact right code, even when your phone is completely disconnected from the internet? Like, say it's in airplane mode. Think about it for a second. There is zero Wi-Fi, zero cellular data, and yet somehow a website sitting on a server hundreds of miles away knows for a fact that the random numbers flashing on your screen are correct. It feels literally impossible, right? I mean, how on earth can they agree on a password if they aren't even talking to each other?
Well, the answer lies in a clever little concept known as TOTP. That stands for Time-Based One-Time Password. It's the brilliant underlying core algorithm that drives apps like Google Authenticator, Microsoft Authenticator, and Bitwarden. Essentially, TOTP is this beautifully synchronized mathematical dance. It's a choreographed routine between your phone and whatever service you're trying to log into. Google, GitHub, your bank, you name it. They are both calculating the exact same code at the exact same time, without ever needing to communicate. So to understand how they actually pull off this magic trick, we have to look at how the dance begins. It all starts with the setup. When you first enable two-factor authentication, or 2FA, on a website, the server generates a completely unique, totally random mathematical key. We call this the shared secret. It usually looks like a super long string of 32 random letters and numbers. Now, let's be real, nobody wants to manually type out 32 random characters on a tiny phone keyboard without making a mistake. So the website conveniently converts that giant, complex string into a simple QR code for you to just quickly scan with your camera.
But the real magic happens the very second you scan it. Your Authenticator app instantly does two things. First, it extracts that shared secret key hidden inside the image. Second, it stores that key securely, strictly locally right there on your physical device. So the crucial point is, and I really want to emphasize this because it's the entire foundation of your security, this brief moment of scanning the QR code is the absolute only time the website and your phone ever exchange information about this specific login. From that moment forward, they cut ties entirely and operate in total isolation. Once your app has that secret safely tucked away, we transition into the independent operation phase. The app now relies on a highly standardized cryptographic formula to generate those familiar 6-digit codes. And the core concept of this formula is actually remarkably simple. Time plus the shared secret equals the code. Now, both the website server and your phone possess that shared secret, right? So the only missing variable required to make their mathematical answers match perfectly is time. And that brings us to arguably the most important number in this whole system, 30. To solve that time variable, the app looks at your phone's internal clock and measures the current Unix time. If you aren't familiar, Unix time is just a standard computing metric that counts the exact number of seconds that have elapsed since January 1st, 1970. The app takes that massive number of seconds and chops it up into 30-second buckets. This bucket number essentially acts as a perfectly synchronized global counter. Because both your phone and the website's server are synced up to the exact same global time, they are always looking at the exact same time bucket number at any given moment. Now, what's really interesting about this process is how a giant time bucket actually turns into a tiny code. It takes some incredibly fast-paced cryptographic math happening completely out of sight. First, the app mixes your current time bucket number and your shared secret together. Next, it hashes this mixture using a complex cryptographic algorithm called HMAC-SHA-1. Basically, this scrambles the combined data into a massive, completely unreadable string of characters. Finally, the app takes a very specific slice of that long string through a clever process called dynamic truncation and converts it into the neat, readable 6-digit number you see. And because that time bucket fundamentally shifts every 30 seconds, the math resets, and the resulting 6-digit code changes right along with it. And this brilliantly illustrates what happens at the precise moment of login. You type your password, the server asks for the code, and you glance down at your app. At that exact microsecond, the website server is running the exact same mathematical formula we just talked about, using its securely stored copy of your shared secret and the current time bucket. If the server's newly calculated 6-digit code matches the 6-digit code you just typed in, the cryptographic dance is a massive success, and you're instantly granted access.
The security benefits of running this entire process locally, completely disconnected, are absolutely massive. First off, as we covered, no internet is required. Your app doesn't need cellular data or Wi-Fi to generate codes. It strictly relies on its own internal clock. Second, it makes you entirely immune to SIM swapping. You know, hackers can often hijack SMS, text message codes by tricking your cell provider into routing your texts to a new phone. But Authenticator codes, they never travel over cellular networks. They stay locked down on your physical device. And third, it's incredibly phishing resistant. Even if a sophisticated hacker tricks you into typing a code into a fake website, remember, that code changes every 30 seconds. By the time the hacker attempts to reuse it on the real site, it's already expired and become totally useless. Let's move on and see how this builds into an answer for a very common, very rational anxiety. What happens if your phone's internal clock is slightly off? Because think about it. If this entire robust security system is built on perfectly synchronized global time buckets, wouldn't a phone clock that's just a few seconds fast or slow completely lock you out of your digital life forever?
Fortunately, software engineers actually anticipated this exact problem. To prevent you from being locked out by minor time drifts, most websites employ a very forgiving validation window. When you try to log in, the server doesn't just calculate the code for the current 30-second bucket, it actually calculates the codes for the previous 30 seconds, the current 30 seconds, and the next 30 seconds. If the code you type into the website matches any of those 3 buckets, boom, it lets you right in. This invisible buffer gives your phone a generous margin of error, ensuring smooth, frustration-free access, even if your device's internal clock is lagging just a tiny bit.
Which leaves us with this final, really remarkable thought. How elegant is the invisible math protecting your daily digital life? It is completely disconnected, mathematically flawlessly synced, and seamlessly secure. The next time you open your Authenticator app and watch that little 30-second timer aggressively ticking down, you're going to know exactly what's happening under the hood. You're not just looking at a randomly generated number, you're looking at the result of a perfectly synchronized, highly secure cryptographic dance happening entirely locally, right in the palm of your hand. If that much brilliant engineering goes into a simple 6-digit code, what other everyday digital magic is just waiting to be decoded? Thank you so much for joining me for this explainer. Keep your curiosity sharp and never stop asking questions about the technology you rely on every single day.